Hey YouTube. Welcome to video number 7 of my little Nix configuration series here. In the last video, we had refined our Hyperland Wayland setup within our virtual machine. And in today's video, I would like to go over the installation from a Flake. Actually, one of the big advantages using NixOS is that you can build out the whole system just from a configuration file. And today I want to show you how you can do that just from booting the and get the fully fledged system out of it with basically just 2 commands. So right now, the easy part when installing a NixOS system is kind of the configuration, because we have built out the configuration in the last couple of videos. Actually, the part taking most of the work when doing a full system installation is basically we need to boot into the ISO and we need to do a manual partitioning, or we need to do a base installation with partitioning and then afterwards apply our flake configuration to the system. Basically, the only part that needs to be done manually is the partitioning part. But there's also a solution for that. So there is a project on GitHub named Disko, and Disko is here to solve exactly that problem. So Disko enables you to declaratively define all your file systems and also your partition table for one or multiple disks. This kind of eliminates the work for doing manual partitioning. So when we just scroll down at the description, you can see a very simple example of this definition here. So we have Disko devices, and here we define a disk with the name myDisk, and this is assigned to a real device, which is in this case /dev/SDA. And then you can see underneath, we have defined the partition table type, and down here we have defined the boot partition. And we also have defined a root partition with an ext4 file system. And here it is defined that this partition should take 100% of the available space. And that's what we are going to build into our Flake today. So when I head back to our code base, I open up my flake.nix file. And the first thing I need to do is I need to define a new input for Disko. So I can just define like this, and my code completion has already offered me the right solution here. So here we define the URL for the Disko Flake, like described in the GitHub description. And here we declare that Disko should follow Nix packages defined up here. So Disko will also use the unstable branch. And what we also need to do is we need to add Disko to our outputs, and we need to add the Disko module to our modules list on the system configuration. And when we load the Disko module into our system configuration, this basically eliminates the need to define file systems in our host configuration. So as you might remember, we had in our hosts folder and the host name, we had 3 files. We had the configuration.nix, the default.nix, and the hardware configuration.nix. And the hardware configuration.nix was the result of the hardware scan, and the NixOS installer also detected the file systems. So when we open the hardware configuration.nix, we can just get rid of the file system definitions and the swap device definitions here, because, as I said, that will be handled by Disko. And now I will create a new file on our host folder. So I will just name this one Disko config.nix. And I have prepared a very simple disk definition that's basically the same as the example I showed you before. So yeah, I would just rename this one NixOS. And as you can see, I have changed the device here because the device my virtualization host is providing to the virtual machine is /dev/VDA. And here I define a GPT partition table with a boot partition and a root partition with ext4. And that's basically the same configuration we have used before in our first video. The only real difference is I think I defined a master boot record, and this time we take a GPT. And in order to have this included into our configuration, we need to add another import to our configuration.nix here. So I will just import disko-config.nix. As I said, on this virtual machine, I have changed from MBR partition table to a GPT partition table, and I also want to get rid of grub and instead use systemd for our bootloader here. So I will just remove this here and just add the appropriate lines for systemd here. And what I would also like to do is I would like to do a little bit of cleanup. As you might remember, under our hosts folder in the common folder, which is shared between hosts, we had the user configuration. We had a symlink here referring to our main username, which is in home, and then our username here. This is a little bit error prone because this is largely dependent on your Git settings. If your Git settings are set to follow symlinks, everything will be fine when cloning the repo. But if not, you need to set the symlink manually like we did in, I think, the first or the second video, and you need to do that each time you clone the repo. And basically the standard configuration for Git differs a little bit dependent on the operating system, the Linux distribution, and which Git package is used really. So I want to get rid of that because that's a weakness in our configuration. When we have a look at our folder structure here in our host common folder, you can see that this shorthand refers to 3 directories up, home, and then our username. And I will just copy this here. And we had in our hosts common users folder and under our username.nix, down here an import statement, which referred to the symlink and to our config networking host name.nix, which in this example would be this file here. And I want to change that to the relative path here. So we are not dependent on the symlink here. So I will just save it. And now I will just delete the symlink up here. And now we should be good to go. And what I completely forgot about was to create a new branch. So I do that now. We create a branch, video number 7. And we added some new files. So I will just make a git add dot. And I will just quickly go through if everything is complete. We have our Disko input, we have our Disko output, and we have the Disko module loaded into our system configuration. We have removed the file systems. We have a Disko config, and we have the import here. And we have fixed the symlink issue. This should be good enough. And just to make sure, I will make a quick Nix flag check. And this is okay. I will just commit this here and push this to our remote repo. And when we have a look at our repo, we have the branch for video number 7. And here we have the Disko input. So everything is fine so far. So now we can build up a new virtual machine. So I will just create a new virtual machine. You could just select the minimal ISO, but just for demonstration here now, it's easier copy and pasting with the genome variant. So I will just take that one and hit forward and give it some memory and give it 8 cores so it's faster building. disk is fine like this, and I want to customize my configuration. We want the firmware here, so I select it first because that cannot be changed afterwards. And now we need to define the 3D acceleration for Hyperland. So I will just put the listen type to none, enable OpenGL on auto, and then we need to go to video QXL, set this to Word.io and enable 3D acceleration. And that should be good enough. And now we can begin our installation. And on our installation, I will just close the installer because we won't need it, and just start the terminal and just make it a little bit bigger. And what I want to do now is to just clone our flake to this machine here. So just copy this one and say git take branch video number 7, just paste our URL. So, and I will just check the status here. So we are on branch video 7, that's fine. And when I head back to the Disko documentation here and just scroll down underneath the example, I get the command I need to execute in order to make our partitioning for us. So I will just split this up a little bit so it's easier to understand. We do sudo nix, and then we have the flag experimental features nix command flakes. And as you might remember, we also have this in our NixOS configuration. And this basically enables flakes for the system. The ISO we have booted into does not have this turned on by default. So when we run this command to get the flake for Disko, we need to enable it for now. And that's what this flag is for. And then we just tell Nix what to run. So this is referring to GitHub Nix community Disko, and it has a flag mode Disko. And now we can just refer to the Nix file where we have stored our partition data. So in this case, we refer to hosts, our host name, and Disko config.nix. And now it will download the flake and install some dependencies in order to run the Disko command. And as you can see, it will install some dependencies. And now it will run a script to create the partitions. And this is quite a long output, but this will basically also tell you if there were some errors, and we don't have any of them. So I will just have a look at our storage. And you can see we have our hard drive, VDA, and we have set up different partitions here. So that succeeded. And now we can basically do a regular install. So we just do NixOS install, and we give it a -- flake. And this really depends on how you want to do it, because what we can do is we can just go back to our repo and we can just refer to the flake like this, give it the archive, and then we basically give it the name of our defined NixOS configuration in our flake.nix file. And as we have already cloned this repo, we can of course do that locally. So we just do a dot and then we give it our NixOS configuration. So just like this. And now it will start installing from our flake. And now it has evaluated our flake and it's downloading and building the packages for our system installation. So as you can see, my internet connection is quite slow. So I will take the time to talk a little bit about Disko, and then I make a cut because this will probably take an hour or something. When it comes to Disko, we were using a very simple and straightforward example, and it depends really what you use Disko for. So for example, when I set up NixOS servers for clients, Disko is very useful because you usually have a very similar structure on the file system. And you can basically just push this to a cloud provider and have a really easy time setting up a new machine. And of course, you can use different Flake templates for different purposes. So for example, you can have full application stacks. So there is not really a lot to do than just installing with these two commands I am showing here. Disko has also a new tool that's called Disko install. And with Disko install, this will basically do all of the things we have just done manually in one step. So what you will do with Disko install is you give it your Flake URL and you give it your disk definition over here. And it will basically do the partitioning and the Flake installation just in one step. I have to admit, it didn't work for me all the time. That's why I decided to show you the way that was working best, in my opinion. But you can try it out for yourself. And when it comes to Disko, you can also make more complicated setups when it comes to file systems. You have a examples folder on the Disko repository, and you can see there are a lot of examples here. So for example, when we take the complex.nix one, you can see this is a configuration with multiple disks, and you can get really sophisticated with this. There are also examples for different file systems. So for example, when you go to ZFS down here, you can see that this also defines a Z pool and the different mount points and so on and so forth. And there are a lot of examples you can use to learn how to use this. I use this mainly when it comes to cloud installations and I want to spin up servers fast. And on my actual working machines like my desktop, my laptop and so on, I still have a hardware configuration because these machines have been installed once and there is not really a need for a complete reinstall because I can just rebuild the system anytime I want and there's no need to install the whole thing once more from the ISO. So that's how I handle it. What's also quite interesting, and maybe we will have a look into that in a later video, is that this Disko tool is also used by NixAnywhere. And NixAnywhere is a project that aims to really take the time-consuming part out of setting up a new machine. So this project enables you to have basically an unattended installation, fully declarative on cloud host. Maybe we will look at that at a later time. So now our installation is nearing finishing. The download is almost ready. I had a little error when I turned on the recording, so I don't have the very last step of the installation. This is actually just prompting for root password and then rebooting the machine. The installation succeeded successfully, and when we have a look here and start the machine, you can see we have a system deboot here and can boot into NixOS now. And of course, I can just take the same credentials we had on the other virtual machine. And as you can see, we have the exact same state of installation that we had on the other virtual machine. So when I open up my terminal, for example, and in the last video, we made something about NeoVim configuration and I start NeoVim. You can see, as in the last video, NeoVim will start installing plugins because we also had the .files repo we have put into our Flake in the last video in here. So that's working now. As you can see, when you have a fully built out Flake file, you can very easily do a full system installation with all the details without any intervention really. So just to round this up, I will quickly have a look at the IP address for my virtual machine and then change our SSH configuration down here to 43. And as you can see, we can connect to the virtual machine because the public key is of course part of our NixOS configuration. And of course we can also make changes to our configuration now. So let's say we go to home.nix and let's say we install Ponysay. And we can push it to our virtual machine as we did before. So when we have a look at our virtual machine here and we do a Ponysay, you can see this is working also. That's it from me today. And if you have any questions, just drop a comment or send me a DM. And in the next couple of videos, we will have a look into some other topics. So I'll go over on how to declaratively use Docker containers in NixOS, because you can also make Docker containers part of your NixOS configuration, and this makes it very useful to get services up and running that are maybe not available on Nix packages. So that's all from me today. Have a nice time. Bye-bye.